Yeah. Sounds like. Yeah.
All right. We can see you, we can hear you. Go for it.
Great. Good evening, everybody. My name is John Hanson. I'm the Assistant Town Administrator and Community Development Director here for the town of Swansea. Thank you all for coming. I'm joined by our friends from SERPED, who are going to be leading the presentation on Compton's Corner Stormwater Planning Workshop. We're also going to have some representatives from Horsley Witten to provide some engineering expertise on different concepts for advancing these stormwater designs. And we really hope that we can elicit some public feedback tonight on these designs and what you want to see. This is your neighborhood. This project was born out of the idea of improving water quality in and around the Ocean Grove area, and Compton's Corner being a perfect confluence of many different drainage areas and outfalls and catchment areas seemed like a good place to start. So please don't be shy. If you have questions, if you have comments, let us know. It makes the plans, the designs that much more reasonable and successful in the long run. So with that, I'll turn it over to Serpent to kick us off. Is that you, Danica, or all right?
You're very ready. Yeah, so well, I'll do an introduction and then I'll yeah. So good evening. Hi, everyone. I'm Danica Belknap. I work at SERPED in our environmental planning department. I'm joined by other members of my team tonight as well, Sarah, Audrey, and Cece, as well as our consultant for this work, Jeff from Horsley Witten, who's joining us tonight. So we're going to talk to you a little bit about the background of this project that led us to ultimately the selection of these sites for potential stormwater management projects. But first, we're going to kick it off with a little video that just kind of gives you a quick overview of the project. So we will start with that.
Ocean Grove is a coastal neighborhood in the town of Swansea. It is situated on Mount Hope Bay in the southeast region of Massachusetts. Ocean Grove sits at the mouth of the Coal River and includes the town beach. Ocean Grove and Swansea as a whole are influenced by the recreational, cultural, and historic resources provided by the water. Historically, Compton's Corner was a site rich in biodiversity and served as a host for local shellfishing due to its populations of American oysters, quahogs, and soft-shelled clams. In the 1970s, the 647 shellfish beds hosted by the river were closed off for access due to significant pollution. However, subsequent water quality improvements since then have allowed some portions of the lower Coal River estuary to reopen conditionally for shellfishing. During certain times of the year or following heavy rainfall, when expected poor water quality makes the consumption of shellfish unsafe, these beds close. The Compton Corner Stormwater Management Planning Project was established by the town of Swansea in partnership with SERPED to address concerns and help improve water quality further. By collecting and analyzing water samples, the project will identify and mitigate sources of contamination and determine how to decrease excess pollution at the site. Identifying how much pollution is coming from each outfall pipe will help determine which areas of Ocean Grove have larger stormwater challenges. The results of our analysis will help us prioritize the best locations in the neighborhood for diverting and treating stormwater. The goal of this work is to design projects like rain gardens and other types of green infrastructure that capture and treat stormwater. Implementation will help to reduce pollution, restore sustainable shellfishing to Compton's Corner, and ensure the health of the Coal River for generations to come. With these efforts, Swansea aims to reclaim its historic shellfishing practices and foster a healthier environment for its residents and future generations.
My name is John Hansen. I'm the Assistant Town Administrator / Community Development Director here in Swansea, and I've been here for 7 years. The first 6, I was the town planner, and for the last year in this new role as the Assistant Town Administrator. So Compton's Corners is right in the heart of the Ocean Grove neighborhood. Where we're standing is sort of a cultural community commercial center. So every time we have a large rain event in the summertime, inevitably the shellfish beds and the town beach will get closed. We do have testing that is done by our shellfish warden for the shellfishing areas, as well as our health agent for the town beach. The stormwater improvements, we're looking at 2. One would be just up the road here on Anthony Avenue with Cliff Avenue for a town parcel that has several storm drains in its vicinity. We're also looking at our COA property just up the road here and seeing if there's any sort of improvements we can make to the parking area, which is all impervious surface, be it rain gardens or even some rain barrels coming off of the roof, which could then assist with watering of the community garden that they have on that property as well. Only within the next couple of months, we hope to get the tree planting going and the crosswalk art project here. We are still in the midst of the design for the stormwater improvements, so that will take a little bit more time, but we're hopeful that the outreach will lead to quicker effects here on the stormwater as we hopefully make it known to the residents here what is causing the pollution in this area and ways to improve it.
Okay, so before we get started, an acknowledgement to everyone that's in this room. I want to acknowledge some of our partners and funders for this work. So the work is primarily funded through the state's Office of Coastal Zone Management, or CZM. We also received funding support from the SNEP network. SNEP is the Southeast New England Program Network. They provided training to the town and members from the volunteers from the community, some of which are in this room, to participate in a stormwater management training series. I'll talk a little bit more about that. We also had support from Save the Bay, a nonprofit in the area. And then for the water quality sampling that we did, we partnered with the City of New Bedford's Health Laboratory and the UMass Dartmouth, the School of Marine and I used to know it, sorry. The University of UMass Dartmouth. And as well as we were also working with Horsley Witten, who helped us with the drainage area assessment and the design of identifying and designing the various stormwater projects. So for tonight, we already went through the video overview. I'm going to give you a little bit more of a project overview, and then I'm going to hand it over to Audrey to go through the details of the project and how we got to where we are tonight. And then we're going to look through the different site options and hand it over to Horsley Witten, who's going to talk about the various designs for the different stormwater options being considered. So again, like I said, the primary funding source for this project was a coastal habitat and water quality grant from the Office of Coastal Zone Management. It was a 2-year project. So we did some planning and assessment. There was the training work that was offered through the SNEP network, the Southeast New England Program Network. Where the town participated over 5 or 6 training sessions. They learned different types of stormwater management practices, how to identify potential sites and projects for implementation, and then they received training on how to design a site. So that was one of the sites that we're going to talk about tonight. The Anthony Avenue site was the site that was identified during that training process. And so the designs for that site are a little further along because of that, because we had already gotten started on that site through that training program. But then with the funding from CZM, we decided to look more widely at the rest of the watershed and to look at additional sites. And right now we are hoping to work with all of you to kind of weigh the different sites against each other and think about priorities for implementation. So the project area is shown in this map. This shows, so what we're really focused on is a series of outfalls that are in right at Comptons Corner, right here, that are draining into the Coles River and Mount Hope Bay. And those outfalls drain stormwater from these drainage areas here. So it's the whole neighborhood of Comptons Corner are all when it rains, the stormwater is all draining into this one location. So with that comes a lot of different pollutants that are contributing to water quality issues in the estuary. So the goal of this program is to identify, try to pinpoint what's coming from each outfall. But I don't want to get too ahead of myself. I'm going to let Audrey talk about how we're doing that. But identify what's coming from each outfall so that we can prioritize different types of interventions and projects.
So, okay, so a little bit more detail. So first was why Compton's Corner? It's the outlet to the bay for a large majority of stormwater. You can see on the map here, Ocean Grove too. And Mountain Hope Bay is a water body of concern. Both the EPA, the town, and the state have all recognized this. There are many different organizations working to improve that site. And as you heard in the video, sometimes the shellfishing gets closed down. And yes, there were contaminants before as well, but we want to try and clean it up the best we can for the habitat and the fishing potential there. Speaking of habitat, there are a lot of birds that come through here. This is an estuary for a lot of different species. So the more we can clean it up, the better it is for them. And that's a main goal of the SNEP network as well. The 4 different outfalls at this site come from 4 different stormwater areas. That point right here collects all of them. And that's, I believe, one of the big reasons this was chosen. And they were made decades and decades ago, if not maybe 100 years. I'm not sure. Those pipes are very old. So these are very grandfathered in stormwater pipes that need a good assessment of what's going on, which we'll talk about in a bit. And then with this, there's a lot of opportunities in Ocean Grove for improvements. I was told just earlier that Compton's Corner used to be a parking lot, and that the COA parking lot used to be an old house, and that there was a lot that actually Compton's Corner was, in his words, not mine, much uglier, and it looks a lot better. And I think we can continue to improve the area and make it a nicer place for residents to come around and walk and enjoy the nature, as well as collecting the contaminants that might be flowing in that direction. And why not pick this source point, this major pivot point, as a location to do it? It's almost perfect in that way. There are other complications why the site is a little tough, but that's something we deal with, and it's not anything on the site itself. And then we, at the beginning of the project, had, as Danica mentioned, partners of many different organizations that we've already listed, but that came together as the ideas were flowing. So the first part of the of this project is the water quality assessment. So we want to know what is here, what is flowing into the water, and where is it coming from. So our team went out into the marsh muck, as you say earlier. And what we did is there are 4 outfalls. They're all a little special in their own way. And to do the water quality assessment, we had to take them at low tide and get what they call the first flush. When you do stormwater testing, it's important to get the first real volume of rain that comes down into the drain. So if you miss that, you're missing a good chunk of the contaminants that are flowing into the ocean in Mount Hope Bay and Coles River. So with this, we went, Sarah Horvit is a researcher at SMAST. I also don't know, it's marine science and something. And her team, it was amazing, was super helpful. And she really thoroughly and professionally trained us on what a stormwater quality testing looks like. And you saw us out there at the crack of dawn because we wanted to get that first flush of rain coming down at low tide, which is about 3 hours of time. If anyone wants to try and figure out the probability of that, it's low. And that was my job. So SMAST and their team not only helped train us and came out there with us to make sure the conditions were proper, we're doing everything as the EPA and MEMA guidelines. Sorry, that's FEMA for Massachusetts, DER, right? DEP, my apologies. We want to make sure that we're squared away and doing things as much by the book and by procedure as possible. So we were able to partner with them on that. And they also did a lot of the sampling for us. So we tested for phosphorus, nitrate, total suspended solids. So that's like, the big stuff, pH, temperature, and bacteria. Now the bacteria is not done at that facility. We actually literally went down the road to do Bedford's facility, their public health. They do a lot of testing for the beaches. Is it safe to swim in the water? That's how we find that out. And they're also an amazing team over there, Christina Eckenreiter. And so we are getting those test results back now. The bacteria was a little quicker, and it is pretty astounding. It was more than I had anticipated myself. So there are definitely contaminants coming out. Now, what are we doing with that information? So we record the flow and the actual water sampling at each drain, and we are recording that which drains are coming out with what stuff, basically. And knowing that, we can try and target which watershed or which stormwater flow to kind of tackle with projects. Go ahead.
The town does water sampling at beaches.
Mm-hmm.
East River, Coles River, Town Beach, and fisheries also does water sampling. You can call it one. And with benign shellfish beds. Are you accessing that data?
No, this was more. So John has access to that data and he knows of the process. For this specific project, it's actually a really good question. We were more looking at specifically for this neighborhood and the stormwater flowing in the drainage areas in Ocean Grove, so that we can really pinpoint exactly in this area, this stuff is coming out. We definitely could look at that data, and I would love to now, knowing all of that. But what we are trying to look at is, okay, kind of more, where is it starting from? Because the shellfish testing, the Coles River, Lees River, that's after it has flown through the drains and kind of gone downriver a little bit more. So we can compare the two and see, potentially on the days that it rained, what were our results compared to what were the results in Lees River, and maybe even see like the correlation there. But that's a much wider scope, I think, than what this project was, which is very site specific. Does that make sense?
It does, and it, 25 years ago, there was a group called River Aware,
Mhm.
actually did, tried to look at a lot of this stuff, mostly on foot. And, but especially in the Grove, and particularly in the Comptons Corner, we were looking for sewage out. And because the Grove was originally a summer colony, it's not anymore. And a lot of the sewage went directly in the river because everybody thought that's okay back then. And Tom, you were able to track down the sources of the sewage, even as far as flushing God, toilets.
Wow.
So I don't know what that data is. The state was involved with it for a while, and then they lost interest.
That would be really
But I
interesting.
can see if I can dredge up that data.
Yeah, if you could, that.
Report. I don't know if it had that.
Let me see if I can find out if it exists.
Yeah, it's hard when everything was paper and then now everything's on the computer. We don't know where the paper is.
So I mean, a large reason why the town and why we are focusing on this area is because of previous studies, but haven't done that happening. So this is kind of building off of that and trying to paint a clearer picture for, okay, what can we do about it?
And you said that was 25 years ago, roughly?
Yeah,
So that'd be like
around 2000.
2000. In my head, I was like, okay, 1990. Okay, that'd be awesome. Yeah, appreciate it. So after we get that information back, after we identify what's flowing in from these areas, then we partner with Horsley Witten, with Jeff, pointing to Jeff, he's a part of, to get some concept designs for tackling some of that filtration, kind of either slowing down the water or filtering it through vegetation so that it can start to filter and pick up those particles before it gets into the bay. And there are plants and forms of green infrastructure, which Jeff will go over, that are really meant to do that and that do a very good job of doing that without impacting the environment too much. And so we asked them at the beginning of the project and then pulled them back in for the 10% designs as well. They helped us with site selection as well, kind of figuring out what's appropriate for where. And one of the greatest things they did was going around to each of the manholes and seeing where is that water flowing from. And so we have a much more accurate picture now of where each drain flows into, which street goes into where, because they went out there with DPW. Some of the stories from those pipes is interesting. Some really kind of mysterious almost, because Swansea is an old town. So there's a lot there. And then the last part of the project process is community input, like this, is workshops, surveys, trying to see what interventions are most interesting for their community. And that way we can prioritize what sites to try and create these interventions on. And then I've also, we all have as a group too, like had many conversations with neighbors about, what kind of amenities would you like? Not, nothing huge, nothing like a large playground, but if we're going to redevelop the site, what could we put there? So it's simple things, like trees, bushes, maybe a bench, maybe a more like grass versus tall grass. So it's very small, but if we're going to do it, we might as well ask everyone who lives here. So for the sites themselves, so there's an outfall here that goes there, 50 is here, 49 here, and 49A there. That's a nice map for that. So in picking out the sites, there were many more, or not many more, but there were definitely more options than these. But the way to narrow it down was through these different characteristics. So existing infrastructure, is there a septic tank? Can we even filter into the ground here? Are there pipes that we don't know about? What does the sidewalk capacity look like? And then reducing contaminants into Mount Hope Bay, that's the stormwater quality results. So when we know that, you know, which area might be more high priority than others. The ecosystem health, it ties into the water quality, but also, is this a suitable place to have, are there birds that are here anyway? Are we going to be disrupting, not that there's any here, but say an osprey nest or something like that. Then feasibility is, who has ownership of the property? What do the right of ways look like? What do the easements look like? Is this something that could be done? Is this something that wants to be done? Are the neighbors okay with it if it's an easement? The second to last one is the compatibility of green infrastructure intervention, which is something Horsley Witten helped us with, is going to the different site options and saying, we could do these different types of green infrastructure here. We could do these types over here. And so that's how we narrowed it down to the final 4. And then lastly is the community co-benefits that I was talking about earlier. Like, do we want a little path moving through? Do we want more tree cover? How can we also improve the neighborhood without doing too much? And also to improve, since we are going to be making an intervention anyway. So I'll pass it off to Jeff from Horsley Witten to talk about the actual designs themselves. He's scrolling down.
You down?
Yeah.
Righty. Good evening, everyone. My name is Jeff Glover. I've been with Horsley Witten. I'm a senior engineer at Horsley Witten. I've been helping design and find these retrofit opportunities for, you know, multiple municipalities over the past 10 years. I'm excited to, you know, and hopeful that these sites that we found will improve the water quality out at Comptons Corner. So I'm going to do this in kind of 2 parts. The first part is the retrofit inventory and the 10% designs that Audrey was talking about. And the second part is going to be a deeper dive into the Anthony Ave design and how that's progressed. So the first thing we did was the retrofit inventory, but also, as Audrey mentioned again, going out into the field. We had several field staff along with the members of SERPED and town staff to delineate or confirm these drainage area boundaries and find any unknown structures that may be out there that we could tap into. Along with this retrofit inventory. And, you know, what we found was, can't really see here, but in bold, this outfall 50, it was much larger than we expected, which was good to know, and it helped, you know, inform SERPED's water quality monitoring. So just a critical point in the design process to make sure we have all, you know, the most accurate data. So from confirming our drainage area boundaries and finding those retrofit opportunities, we then turn to our GSI toolbox. So this is what Audrey was mentioning, you know, what we use to help filter the water, and how we can fit these types of practices, these types of GSI practices that will help, what we're trying to do is mimic nature and help water get back into the ground and filter that water and remove those pollutants. And these are just a few examples of both structural practices and non-structural practices that we use to, you know, reach this goal. As far as retrofitting is concerned, it takes a little bit more creativity when you're trying to put these into an existing landscape or an existing development, or, you know, along a roadway, right? Because you're trying to use what's there already. You're working with the existing topography and you're working with the existing drainage infrastructure. And again, these are just a few examples of, you know, where we were able to fit in green infrastructure where, there was an existing boat ramp or an existing roadway, another boat ramp. We had a boat ramp project on the Cape, so that's where a lot of these are from. I was going the right way. All right, so a total of 10 opportunities were found, but we narrowed that list down to that top 4 that Audrey mentioned that were pinpointed on the map. The first one, R1, bioretention at Comptons Corner. So this is right near that confluence of outfalls, right? So what the goal of this would be is to intercept the drainage that's coming off the roadway and put in a inlet that would then go into a depressed landscaped area, which with a bioretention or a rain garden, very similar in function. Bioretention just has a little bit more infrastructure. So there's an under drain and it connects to the existing infrastructure. You're going to have a better look at these on our boards, but just like I was explaining, an inlet to a sediment forebay here, taking the runoff from the road. And then this dashed line here that runs across the screen, that's the existing pipe that we would then tie into. It's a similar, I guess, practice or condition at all the sites. We're trying to reuse the existing drainage infrastructure. R2, Harvard Street wet swale or wetland. So this is that larger drainage area, and this is where we found that it kind of expanded to the upper neighborhood. But at the same time, we found this opportunity where there's this space of, it's undeveloped, it's on a paper street, meaning it's town owned, and there's a drainage line that's running right through it that we could utilize. This is a little less descriptive of a graphic, but just of where the water is coming off of the impervious surface, and doing some light to moderate grading in this area to try to produce a natural wetland system, mimicking nature, which would then overflow into the existing drain line. So the Massasoit and Metacomet tree trenches, this would be, taking runoff from the road. A lot of these are, you're seeing, or this one and the last one are, they're in these public right-of-ways, town-owned areas. So we're trying to utilize that, and it's the best opportunity for picking up impervious surfaces, as far as where it's coming from, and you can collect it right at where the collection point is. So as far as what we would do here, propose an inlet here. Actually, no, that's an existing inlet. I'm sorry. So remodify this existing inlet. And what we would do is we dig down about maybe 4 to 5 feet, and we'd fill this trench with gravel. So what that does is provide storage, but allows for infiltration back into groundwater and recharge. Yes, sir.
Are you putting a street here to install a trench?
No. We wouldn't take any width of the street. No, it would be within the right of way. That would be the goal. Yeah. So also incorporated in this conceptual design is a distribution pipe. That's what this line is. So this would be a proposed distribution pipe that allows the water to feed to the infiltration trench. And just an example of what this would end up looking like, so during construction, yes, it's a big mess, but once you fill it back in and everything's online, it just looks like a couple of street trees, but it's functioning as green stormwater infrastructure. And the last one is actually right out this window. So this was one of the original sites identified by Serped. This is the parking lot where we are here. So this is a cool opportunity. Another cool thing. So I know I'm going quickly through those and through these, and we can talk about them in more detail, but we're using a bunch of different tools, like I mentioned, our toolbox. It's not just one thing fits all. We're trying to use see different opportunities and fit in different types of green stormwater infrastructure where we can. So this would be removing or modifying a part of the landscape and then removing the sidewalk that doesn't necessarily get utilized, and putting in another depressed landscape area that would like run off from the parking lot through a series of inlets along that far edge. All right, so now I'm going to get into the Anthony Ave design, which has been moved from 30% to a 75% design, which we completed. 30% we completed back in fall. Well, we're just about there in the 75% design, but we'd like to talk the changes through with you and what you're eventually going to see out there. So this lot is on the corner of Cliff and Anthony Ave. It's town owned. Currently, the drainage isn't necessarily functioning properly. There's been a lot of changes over the years, as far as like what the historic drainage was and how it was improved or upsized. So there's some funky stuff going on. Just tough to figure out from a retrofit perspective. And as you can see, it was just dense with vegetation. There were a few native trees that we're going to try to save out there. But definitely we're going to try to clean this up and also provide some stormwater treatment and benefits. So this is the drainage area. So it's about just under half an acre of impervious area. I forget what this road is, but there's a few catch basins here. So that's our high point, and that flows down Cliff Ave and Anthony Ave. There's a high point here, and that's flowing back this way. And these structures those are existing structures that are handling the rest of Anthony Ave. And then this is the design. I'm also going to show a rendering of what it may look like, just from a photo that we took out there. But the design components, so this is an infiltration basin, which is similar to bioretention, but we're using the existing soil. When we went out there, we did soil investigation. So we did a test pit to identify what types of soils were underlying. We found that it was sandy. So when we see that, we can utilize that sandy soil because it has a high infiltration rate. There will be a sediment forebay included as well, which helps with pre-treatment, and that's collecting any of the heavier solids that are coming off of the impervious areas. After it flows through the sediment forebay and into the infiltration basin, sorry, I'm skipping ahead. So this is sized to treat the water quality volume. So the water quality volume is the first inch of volume that forms on the impervious area that we have calculated in our drainage area. So that's a set volume. And then this basin, the shallow, it's about 6 inches deep. This basin is sized to handle that volume and infiltrate that. Yes.
So this is design, for instance. What maintenance is involved with it to keep it functioning properly?
That's a good question. So this is why. So our forebay here, we try to put that as close to the street as possible. So that's going to need the most maintenance. And as long as that gets maintained on an annual or biannual basis, nothing else should really be maintained.
And that can be maintained with a bucket truck.
Shovel. Yeah. So the depth of the sediment forebay is about 3 inches. Mm-hmm. So once it reaches that capacity, and it should be, recorded or inspected, I mean, maybe 4 times a year, and just looked at just to see if it's reached capacity, and then you come out with a shovel and some wheelbarrows. Yeah. There might be some weeding, and especially during the first few years as plants are getting established, we're going to have a planting plan along with this that has native vegetation that's incorporated into the design. During that establishment period, there's going to be there's going to be a period that you need to check on the plants, make sure that they're healthy until they get, solid roots and they start repopulating.
When you've done these projects in other communities, have you engaged with community groups to help maintain it? Like, getting planted and
Right.
plantings going.
Well, we've done planting days, and we've done like maintenance days, but I think that'll be on the towns, since they'll have ownership of, they'll own the maintenance. I mean, if a community group wants to adopt that, then
I was just curious of what it worked as.
yeah, it absolutely has. We have our own adoption site in Sandwich, where we're headquartered, where we do annual to biannual maintenance at the local library. Yeah. Because usually, yeah, if you don't have the proper guidance on maintaining something like this, it just gets mowed. And we're putting plants in here that are, they're flowering, they're local pollinators, and that those sometimes just will get chopped down if the maintenance guide is not followed. But yeah, it's a great question. I mean, ultimately, it should be self-sustaining, other than the 4-bay. And then real quick, so once it reaches capacity after that first flush, that 1 inch water quality volume, we have an overflow structure here, which is going to connect into the existing drain line, which then flows out to Comptons Corner. So at that point, it'll be treated, clean stormwater. And this is the rendering. So just a wall of, I mean, like I said, there are some native trees in there, but plenty of vines. I'm sure they're bittersweet. I don't know if there's any knotweed, but
Some Norway maple in there.
I'm sure there's some Norway maple, maybe some sapling. No, there's some good ones out there. They might show up on here as far as red oak, cherry, silver maple, ash. Yeah, there's some good trees. And we're working around those. Another thing I forgot to mention, also incorporated in the design of the stormwater treatment, we kind of want to make it somewhere that a place where community members can come and enjoy. So we've included a walking path. It, for the most part, goes around the perimeter of the basin. But maybe future planning, or it could connect into something bigger. But as far as education, providing a place to sit down and enjoy and watch the function of these stormwater treatment systems happen.
Okay. So
Next.
yes, thank you. What we are going to ask you all to do, if you'd be so kind, we have, so that Anthony Avenue site is 75% done. The designs are quite ready to go for that. For the prior 4 that Jeff was explaining, we have them listed here with some of the, to the left is the actual picture of the site, and to the right is kind of more of a technical, what it will do and help to do. I'll bring this map over as well, but you can see which are 1, 2, and 3, 4, where those locations are as well. So we have voting slips, and if you could just write down the ones you like, or any of the comments that you have, that would be great. We also have sticky notes if you want to put it right onto the board. We're trying to be as accessible as possible. So that will be the activity. But as far as next steps in the project, so first we have your input and any other community members' input. We'll put a survey out as well. For the next couple of months, will be open for John to see and utilize. And then with that, we have the prioritization of these 10% designs, so that we can secure permitting and design for those 10%. I'll say the retrofit 4 over there. We can start the permitting process there, so that when the town chooses to apply for grants or seek other forms of funding, they'll be ready to go. so that you don't have to wait quite as long. And that process might take 1 to 2 years, depending on accessibility of grants, accessibility of funding, willingness of partnerships and things like that. Then finally, the construction may take, and this is a timeline from now. So 1 to 2 years, we could find this, and 1 to 3 years, we could do that. And after we secure the funding, get the permitting, then construction will begin, which could take 1 to 2 years, depending on the circumstances of the site itself. Comments or questions, we'll move to there. And then here is John and I's information if you want to get in contact with us. I also have my card, but I'll move back to this slide so we can have this map up and talk about the activity. And then if you'd have any comments or questions now, we can have an open discussion as well. So I'm going to turn the lights back on. Okay.
So most of this is the vegetarian.
Yeah, that's right. She usually they of the tree. Right. And we try to identify places or spaces